Bismillahirrahmanirrahim. I am Harun Ashraf, your teacher of science. Alhamdulillah, I am fine and I hope that you would be fine and healthy. Students, the course of science in the second term will be started with effect from chapter number 5. Chapter number 5 in your textbook of science is related to the concept of atoms, molecules, mixtures, and compounds. Dear students, as in your previous classes you have studied about the concept of matter, you remember the definition of matter, that matter is anything that has some weight and occupies some space. Whatsoever the state of the matter may be, the fundamental building block of the matter is called atom. Atom is the smallest particle of the matter which can take part in a chemical reaction. Dear students, we cannot see atoms because they are so small. It is not like a cell in the living organism that can be seen under a light microscope or electronic microscope. Atom is such a smallest particle that cannot be seen even with the electronic microscope. So, but different theories have been given about the structure of atoms. Niels Bohr's atomic model, Niels Bohr, who was a French scientist who presented a theory about the structure of the atom, that is called the Bohr's atomic theory. That is very popular theory, and according to that, the shape of the atom or the structure of atom is just like our solar system, where the nucleus is at the center of the solar system, just like the sun is at the center of the solar system and the planets are revolving around the sun. In case of atom, the electrons are revolving in different circular shells in different orbits. So the structure of Niels Bohr was just like the structure of the solar system in our universe. Students, atoms except the noble gases cannot exist independently because atom is so small that cannot exist independently. Most of the atoms, they react with each other, they cooperate with each other, they form the chemical bonds and then they can exist with each other, just like the example of oxygen gas. Two oxygen atoms combine with each other through covalent bonds and oxygen molecule O2 is formed. Because oxygen is not a noble gas, it cannot exist independently. But in the periodic table, in the 7th A group of the periodic table, there are noble gases like helium, neon, xenon, argon and krypton. These are the noble gases whose atoms can exist independently. The smallest group of the atoms, may be two atoms, may be more than two atoms, can join together to form larger particles of the matter, that is called molecule. Molecule is such an entity, such a particle that can exist independently. So the atoms may share by covalent bonds, they may share by coordinate covalent bond, they may share by ionic bonds. So there are various methods of sharing of the atoms. Once the molecule is formed, that is the stable structure. For example, two oxygen atoms share with each other to form oxygen gas. One molecule of oxygen gas is made of two similar oxygen atoms, and now this O2 is called oxygen gas that exists independently. Let us describe the properties of the molecules. Molecules can exist independently. Molecule is such an entity, is such a particle that can exist independently in the universe. Unlike the atoms present in the molecule, We know it that atoms cannot exist independently, but once the molecule is formed, it can exist independently. Sometimes it happens that there is only one kind of atoms present in a molecule. Sometimes it has some different types of atoms present in it. In an example of oxygen gas, one oxygen molecule O2 is formed by combining two two oxygen atoms that are similar in size, in shape, in all regards. Those are similar to each other, but two oxygen atoms combine with each other to form oxygen molecule. In an example of water molecule H2O, two hydrogen atoms combine with one oxygen atom and a molecule of water H2O is formed. So in this example, there are different types of atoms present in the molecule of water. Students, at the start of the chapter, I told you that there are three states of the matter. Those are liquid, solids and gas. Mind this thing, liquid, solids and gas are the states of the matter. But we will switch to the types of the matter now. There are three types of matter. Those are element, compound and mixture. Chapter number 5, which we are studying, that is about three types of the matter. Number 1, element, number 2, compound and number 3, mixture. We will study the definitions, the properties and examples of three types of matter in detail in chapter number 5. Let us take start from the concept of element. Student, the element, the simplest definition of the element is such that it is a type of the matter that consists of only one kind of atoms in it. For example, gold, silver, copper, maybe hydrogen, maybe chlorine, nitrogen, sodium, potassium, aluminium. So up till now 109 elements have been discovered. So by definition of element, it is such a type of matter that consists of only one kind of atoms present in it. Then an example is there. If we take a piece of coal, which is actually carbon, coal is actually the allotropic form of carbon, and we break it into very small pieces, we will come to know that its very small piece is also carbon. It means it is such a type of the matter that cannot be broken down into further simpler substances. Element is such a type of matter that cannot be broken down into simpler substances. So even if the small piece will be coal, smallest piece of this sample will be coal. So coal means carbon. It means element cannot be broken down into further simpler shapes, into further simpler substances. So the same definition have been given at the end in point number 3. Elements cannot be broken down into further simpler forms by ordinary chemical processes. It means elements may be broken down into further simpler substances, but by various complicated techniques we can break the element into simpler forms. But in most of the cases, the elements cannot be broken down into further simpler forms by ordinary chemical processes, means by ordinary laboratory methods. The elements cannot be broken down further. In order to avoid the complexity, or for the sake of convenience, the scientists have divided the total 109 elements into two main classes. The first class is naturally occurring elements and the second class is artificially prepared elements. So out of 109 elements, first 92 elements are naturally occurring elements, and the remaining 17 elements were discovered by the scientists in the laboratory by different artificial methods. As earlier we discussed that matter exists in three states, that is solid, liquid and gas. As element is also a state of the matter, therefore element also exists in three possible states, that is solid, liquid and gas. There are some exceptions. Mercury is a liquid element. We all know that the mercury is a metal. All the physical and chemical properties of mercury represent that mercury is a metal, but it is not in solid state. At ordinary temperature, mercury exists in liquid state. So therefore it is called a liquid element. Helium is a noble gas, inert gas, but that is found in the gaseous state. So these are three states of the elements: solid, liquid and gas. In order to avoid the complexity in the periodic table, scientists have decided the abbreviated name of an element instead of the full name of the element. So the abbreviated name of an element is called symbol. A symbol is the abbreviated name of an element. Each element is given by a symbol. In the beginning, what was the practice? Each element was written in its full name. For example, full name nitrogen, full spellings were used, Nitrogen, and similarly for hydrogen, Hydrogen. These full spellings were used in the periodic table, but it was a difficult practice. Therefore, scientists decided the abbreviated name of the elements in the periodic table, and that is called a symbol. So a symbol consists of one or two letters taken from the English or Latin name of that element. So English alphabets or Latin language alphabets may be used for the symbols of different elements. For example, capital H is the symbol of hydrogen, that is taken from its English name hydrogen. Capital H is adopted. And Na, capital Na, this is the symbol of sodium, whose Latin name is natrium. So S, capital S is not used for the symbol of sodium because it is duplication. Therefore, the symbol of sodium was decided after the Latin name of sodium, that was natrium. So capital Na is the symbol of sodium. And different symbols have been given to you in this table. That is, for example, the symbol of copper is Cu, symbol of potassium, that is a metal, that symbol is capital K after the name of kalium, that is the Latin name of potassium. Similarly for iron, they have used capital Fe, which stands for ferrum is the Latin name of iron. Similarly mercury, Hg. Similarly fluorine, capital F symbol is used for it. For silver, capital A and small g, Ag, this symbol is used for silver because the Latin name of silver is argentum. For the gold, they have used the symbol capital Au. Au is a symbol of gold. Co, C capital, O small, this is the symbol for cobalt. For the convenience, scientists have further classified the elements into two classes. First is the metal and second is non-metal. Metal elements are about 70% in all the elements in the periodic table. They have similar properties. What are those similar features found in the metal elements? Number one, the most of the metals are shiny or gray solids and they can be molded or shaped by heating and pressing. So this is the first common property, that all the metals are shiny and gray solids and can be molded in any shape by heating and pressing. Metals are very good conductors of heat and electricity as they allow them to pass through. So it is our common practice that very good conductors of electricity are also the good conductors of heat energy. So metals are good conductors of electricity and heat. Some common metal elements are given in the table along with their symbols. So these are some examples of the metal elements taken from the periodic table. Element, the name of the element and the symbol. First, antimony, this is an element, metal element, the symbol is Sb. Copper, Cu. Gold, Au. Iron, Fe. Lead, that is also called plumbus. So the symbol of lead is Pb, which is a metal. Mercury is a metal, you know. Hg, Hg is the symbol of mercury. Potassium is represented by capital K. Capital K is a symbol of potassium. Silver is denoted by Ag, argentum. Sodium, Na. Tin, stannum, that is Sn. Tungsten, W, that is wolfram. Wolfram, this is capital W. So the remaining 30% elements in the periodic table are the non-metals, which have entirely opposite characteristic features as compared to the metals. So non-metals are such elements which are not metals. So the common features are they have different properties from the metals. Non-metals can be solid, liquid or gas, because even non-metals are elements and the elements are the types of matter. Therefore, the non-metals also exist in three states: liquid, solid or gas. Solid non-metals are brittle and you cannot mold or shape them. You cannot mold or shape them, the non-metals. Most of the non-metals do not allow electricity and heat to pass through them. So this is entirely opposite feature as compared to the metal elements. Metal elements were very good conductors of heat and electricity, but most of the non-metals do not allow electricity and heat to pass through them because these are non-conductors. Non-metals are non-conductors. Some examples have been shown to you. Carbon. Carbon, very famous element, but it is not a metal, it is a non-metal. The symbol of carbon is capital C. Hydrogen, this is a gas, you know. Hydrogen is the simplest element in the periodic table. The periodic table actually starts from the element hydrogen, but hydrogen is a gas, therefore it would be non-metal. Oxygen, that is also a gas. This is a ideal gas, and oxygen is denoted by capital O, which is a non-metal. Chlorine, this is again a gas which is a non-metal. Nitrogen is a gas which is non-metal, and sulfur is a non-metal that is found in the powder shape. So sulfur is a non-metal that is used in the explosive materials and in various chemicals, but it is a non-metal. So as usual, the assignment is given to you, that are 6 short questions. You will give answers to these short questions and will send it to me on my email address mentioned below. So student, wish you best of luck. Inshallah, in the next lecture we shall continue this chapter in more detail. Thank you very much.